Hey there, welcome to a session on Introduction to Percentages. Percentages are not only essential for the SAT, but also extremely practical in real life situations. This session will help you master the basic, solve tricky percentage problems, and use tools like Desmos to make problem solving easier and more visual. Are you all ready? Let's dive into the world of percentages. Percentages form the foundation of many SAT math problems, so it's crucial to get comfortable with them. First of all, definition of percentage. Percentage represent a fraction of 100. Anything that represents in terms of 100 is a percentage. For instance, if I write 50%, it actually means 50 divided by 100, which is more or less 1 by 2. Or in decimal form, we can write it as 0.5. This simple concept is used everywhere from discounts while shopping to exam scores. Importance in SAT math. SAT questions often include percentages in word problems, data analysis, and even geometry. Understanding how to approach these problems will boost your confidence and accuracy. Using Desmos for SAT success. Desmos can help you visualize percentage problems and verify your calculations. We'll explore this further as we go ahead through the examples. So keep your focus sharp and let's move on to the basics of percentage calculations. Converting percentage to decimals. To work with percentage, we often convert them to decimals by dividing by 100. For example, I'm writing 25%. I can convert it to fraction. We're just removing the percentage sign. I'll write 25 divided by 100 and simplifying it to get a fraction that is 1 by 4. This makes calculation much simpler. Utilizing Desmos. Desmos is great for handling percentage. You can use it to create graphs or perform quick calculations. So for example, if some function is given to you that is y is equivalent to 0.25x, you can definitely plot it and you will see the values for 25% and any value related to the output. For example, I'll just create it. It's y is equivalent to 0.25x. You can see the function is being plotted and you can see relevant values whenever needed. 24, 24, 25. Step-by-step problem solving. Always approach percentage problems methodically. Start by carefully interpreting the question, identifying the given values, and setting up the correct formula. Now that we have reviewed the basics, let's tackle percentage word problems. Translating words into equations. The key to solve word problems is breaking them down into equations. For example, a question says 25% of a number is 50. So how we can write it? We know 25% can be written as 25 by 100. Of means multiplication. A number, for example, that is x, is means equals to, that is 50. And that we can solve with a basic equation of mathematics, which is more or less 0.25 x is equivalent to 50. You can directly use the regression in the Desmos and figure it out that value. So 0.25, I'm writing x1 as it is a regression variable, regression to 50. The value of x is 200. So we clearly know now that 25% of 200 is 50. Graphical representation. Desmos can help you understand these problems visually. For instance, graph the equation y is equals to 0.25x that we just did to see the relationship between x and y. So it will give you the clear relationship. A stepwise strategy. Follow structure step, read the problem carefully, define variables and set up equations and solve symmetrically, always. Word problems becomes easier when you translate them correctly. Let's move on to understand percentage increase and decrease. Percentage change, the concept of percentage change. Percentage change measures how much something increases or decreases as a percentage of its original value. So the basic formula that we'll be using for the percentage change is basically new value minus original value whole divided by the original value times 100. That basically is your percentage change major formula. Application to SAT questions. SAT often asks about change in price, population, or scores. For example, if a population increases from 1000 to 1200. So let's take a simple example that a population increase is happening. So let's say in year 2000, the population of a certain city is 1000 people. So this is year and this is population. So you can see that in year 2001, the population becomes 1200. We need to see that how much percentage increase has happened from 1000 to 1200. So how are we going to solve that? We just use 1200, that is the new value of the population, minus the original value, that is 1000, divided by 1000 from where the change is happening into 100. And that will generate further simplification. If it is done, it is 200 divided by 1000 times 100. You can cancel out these two zeros from here. One zero get cancelled over here, which is more or less 20%. You can see that the overall change that happened from 2000 to 2001 is 20%, and it's an increase. Double check your work. A common mistake is misidentifying the original value. Always double check with value is being compared. So yeah, definitely look forward for original value from where the values are being changed. Make sure that that value is correct. Understanding percentage change is crucial for solving a variety of problems. Let's now explore more advanced topics. So determining the percentage change. So formula for percentage change, as I already write that. I'm taking one more example to elaborate that thing back again. That for example, the price of the product increased from $50 to $60. So the price increases from $50 to $60. What will be the change? So we can easily say that the price has been changed from 50 to 60. So your new value is 60, your old value is 50, and from where the price is changed is actually 50 times 100. And when you solve this thing, it is nothing but it is 10 by 50 times 100. And we know that 50 is 2 times 100. The overall percentage change happen is 20%. There's a 20% increase in the price that we can say. Interpreting the results. A positive result means an increase, while a negative results means a decrease. Definitely, whatever the results we have generated so far is positive. Let's work with an example that generates a negative result. For example, the value drops from $100 to $80. Now, in this case, a decrease is happening. So what is the percentage change? Now, be very crucial with respect to the values, new values, or the original values. So we'll see that in this case, your new value is 80 and the original value is 100. So what you do 80 minus 100, whole divided by from where the change is happening from 100 into 100. So we'll see that 80 minus 100 will generate a value that is negative of 20. Definitely 100 will get cancelled from the bottom. So negative 20%, a negative sign shows that there's a decrease. So we can say 20% decrease is happening. So always remember, a positive results indicate an increase, whereas a negative results indicate a decrease. Avoiding common errors. One common mistake is mixing up the original and the new values. So always divide by the original value, not the new value. Double check your calculations, especially when interpreting word problems or multi-step challenges. Percentage change is not just a calculation, it's a tool for analyzing trends, comparing values, and solving problems, analysis problems. Let's use this principle as we continue. Solving compound percentage problems, multiple adjustments. Compound percentage problems involve sequential changes. For instance, if a price increases by 10%, so what is happening that a change will take away 2 or 3 more times. So let's consider two case change. That if a price increases by 10%, so there's a 10% increase in the price. And then it decreases, followed by a decrease of 20%. You must calculate each step separately. If you want to, you can calculate each step separately. But there's a formula that is being used to calculate the net effect of the two percentage change values. Net effect is calculated as A plus B plus AB divided by 100. Now this formula is being used to calculate the net effect of two percentage change values. Now if such a situation is there that there is an increase of 10%, that means that this 10% the value is plus 10. A 20% decrease represents a value of minus 20. So for a similar formula to get the net effect of both values, we can put the value of A as 10 and B as minus 20 to generate the net effect. So I can say that net effect is nothing but 10 minus 20. So a positive value multiplied by a negative value, if I just write that, plus 10 times minus 20 whole divided by 100. Definitely a two zeros will get cancelled with these two zeros, but a minus 2 multiplied by 1 is actually minus 2. So that will generate a value equals to 10 minus 20 minus of 2. The overall thing that is happening is 10 minus 20 minus 2, that is minus of 22, minus 22 plus 10 is actually minus 12. So a 12% overall reduction has been taken care. We can say that there is a 12% decrease overall. So that is a sequential change. If you want, you can find the net effect of two percentage change, or you can use them step by step separately. Regression modeling with Desmos. Desmos can represent these changes graphically, so plot the relationship to validate the solution. Very common pitfalls. Watch out for errors in interpreting or calculating sequential changes. Write each steps clearly to avoid confusion. Compound percentage problems require careful attention to detail, but they are manageable with practice. Let's understand about mixtures and concentrations. So understanding mixtures. Mixture problems involve combining components with different percentages. For example, I'm just giving you an example that we'll be mixing 10% sugar solution with 50% sugar solution to get 30% sugar solution. So that is how the examples are being made. So there are two cases. For example, this mixture is 10% sugar solution. This is 50% sugar solution, and the resultant is going to be 30% sugar solution. The meaning of this thing is that this green sugar solution is more or less something which contains only 10% sugar and rest is water. 90% is water. 50% sugar solution means that I'll be having 50% sugar and 50% water in it. And resultant is going to be 30%. That means 30% sugar is and the 70% is water. So that is how the things get. Now, based on this thing, we need to form the equations. To set up equations to represent the quantities and concentrations. For example, if you are mixing 5 liters of one solution and 10 liters of another, the equation might look like. So let's see that. So the equation may look like that if I just mixing 5 liter of one solution, 5 liter of one solution and 10 liters of another, the equation may look like that 0.1 times x plus 0.5 times y, which should be equivalent to 0.3 times x plus y, right? So where x and y is the number of liters that will be used, and you will see that this is 10%, 50%, and 30%, which can be written as zero point 0.1, zero point 0.5, and zero point 0.3, where x is represented as 5 liters and y is represented as 10 liters in the particular equation. Using Desmos for verification, graph these equations in Desmos to check your work and find the solution visually. Definitely, we can write the equation, figure it out the values of x and y if needed, and we can definitely see the visual representations too. Mixture problem tests your ability to model and solve equations. Let's solidify these ideas with examples. So I hope the basic agenda is clear. Let's just jump towards some problems and understand all of these with the help of Desmos. So I'm starting with the very basic examples and let's see how we can use them. So the very first question is being given to you that out of 1000 cats that were given treats, 85% purred. How many of these cats purred? So we just need to find 85% of 1000. Desmos is very much good in that. If you write percentage sign, off is coming automatically. So I'm just writing 85. The percent is actually shift 5 key. So percent when you write off is coming automatically. You just need to write 1000. You will see 850. 850. So the correct answer is 850, option number A. The question number 2 says a sample of salt water is 5% salt by mass and contains 500 gram of salt. Which of the following is closest to the mass in grams of the sample of salt water? That means a sample of salt water is 5% salt. So what I can say if I consider this, the whole thing as S, so I'm just saying that 5% of S, it should be equivalent to 500. So I'm just using regression, which is giving me 500. So I just need to find the value of this S. As the sample in grams, the closest mass we need to find. So let's see. I'm just writing 5% of S as a variable, a sign of regression, 500. It will generate a value of S equivalent to 10,000. So what is the closest in mass in grams? So that is 10,000. Option number A will be the correct answer. Let's look at towards question number 3. It says out of 500,000 birds, 475,000 birds are blue. So what percentage the birds are blue? Are we going to use Desmos directly? Definitely simple calculation can be done. It's like 475,000 divided by 500,000 times 100. But we need to use Desmos directly. So let's say that P% of 500,000 birds is actually 475,000 birds. We can say that. So I'm just interpreting that thing. I'm writing P%. I don't know the percentage. P% of 500,000 birds is equivalent to 475,000. So I'm just using regression for that again. 475,000 birds. So let's use that. You just use a variable p, a percentage sign of 500,000, a sign of regression, 475,000. You will see that the value of p comes out to be 95. So p is nothing but 95%. So option number D is correct answer in this case. Moving ahead towards question number 4, it says in a class of 50% of the students are girls. Out of all the girls in the class, 40% participates in sports. So what percentage of students in class are girls who participated in sports? So there are 50% girls, and 40% of these 50% girls worked in sports. Definitely, we can say that whenever we are dealing with a percentage, we know that the total value of whole class should be considered 100, right? So they are 100% people. So what we need to find? We need to find 40% of 50% of 100. So that will generate the percentage. So we can say 40% of 50% of 100. So that is 20. So what percent of the students in the class are girls who participated in the sports? That is actually 20% of the whole class. Let's look at towards the next question. Now the question says, Maya, a working part-time at a cafe, she earned $8 per hour for the first 8 hours. So if you see the highlighted portion, she is getting $8 per hour for the first 8 hours that she'll be working. And due to her excellent performance, her manager increases her pay to $12 per hour for the remaining hours of the week. For the remaining hours, we don't know what the remaining hours are. And Maya saves 60% for his total earnings from each week. What is the least number of hours she must work? So we need to find the least number of hours she must work at a higher pay rate to save at least $240. So that is the basic information provided in the question. Now, what we need to find is actually very clear. So we know that 60% of the total value that he's be earning. So if we talk about the very first case, that 8 per hour for first 8 hours, that means the value that she'll be earning is 8 times 8. Plus, for extra hours, she'll be getting like 12 per hour for the remaining hours. As I don't know the number of hours, so I'm considering the remaining hours as H. So I can write that as 12 times H. That should be at least 240. So I'm just regretting it to 240. At least actually means greater than or equals to, even you can use the greater than or equals to sign if you want to, but that will show you visual representation, but we need to find the remaining number of hours. So I'm just regretting it to the closest to 40. Let's find the value of H. If I use the Desmos directly and put this equation into it, 60% of 8 into 8 plus 12 times H, sign of regression to 240, you will see that the value of H stands equivalent to 28. That means the number of additional hours she needs to work is 28 hours. So option number A, 28, will be the correct answer. Let's have a look on another question, question number 6. It says a dog shelter plans to purchase the same type of collar for each of their 50 dogs. So they've been purchasing some collar for their dogs. So 50 dogs they've been purchasing. The total budget to spend on these collars is $8,000, which includes 10% sale tax. So whenever we have sale tax, that means that is being included inside of it, and it's an extra uh, expense. So which the following is closest to the maximum possible price per collar before sale tax the shelter could pay based on their budget. So let's see that we know that $8,000 should be included, and if 10% is the sale tax for the price, that means 100% is the price plus 10% extra they need to pay. So that will generate 110% of the price. So let's see if we just regret it to see the results, we can easily figure it out that. So you can see I'm just writing the same equation, 8,000, the sign of regression, 110 percentage percent of some value P. I don't know what P is. So the value of P stands very, very big, that is 7272.72727. But this is for all the dogs all together. We need to find the value for per dog. So if I divide P by 50, it will generate a closer result, which is 145.45. So the value stands equivalent to 145.45. So we need to find which of the following is closest to the maximum possible price per collar. So per collar, the value stands $145.45. Even this can be done in a single calculation also. Let me help you with that. So if I just put the total value for 50 dogs, it can be written as 110% of 50 all price. That is, for example, I'm taking another variable P2 and then I'm regretting it with 8,000. So that is also possible. You can get the result in one go. So let me do that also. 110% of 50 P2, a sign of regression with 8,000. So we'll see that the value of P2 is 145.45 directly. So that will be my result. So yeah, option number A, 145.45 will be the correct answer. Let's move ahead to the next question. Question number 7. The question says that last year Saraj apple tree produces 120 bushes of apples. So there's a production of 120 bushes. This year, Saraj increases the number of apple trees by 40%. If an apple tree produces apples at the same rate per tree as last year, how many bushes of apples can Saraj expect to produce this year? So let's see. So again, if we want that if the last year it is 100%, then it's increase of 40% that is happening this year. That means a total of 140% is there, right? It can be done in two different ways if you want to. Let's see. So actually what I'm finding is just finding 120 plus 40% of 120. That is something I need to find. So I'm directly writing it 120 plus 40% of 120. That is 168. That is 168. Or it can be solved as we know that the total value is 140%. So just write directly 140% of 120. So if I just write that 140% of 120, that is again 168. So you can do either ways, both are correct. So 168 will be the correct answer for this particular question. Now let's have a look at this particular question. This says a survey on reading habits in the United States reported that in 2015, adults spent an average of 5.8 hours per week reading books. So in 2015, 5.8 hours per week is being spent by some adults on reading books. The survey also reported an average of 2016, that in 2016, 5.1 hours per week is reported. Based on the survey, how did the average number of hours that adults spend reading books per week change from 2015 to 2016? So that we need to find that what is the percentage change happened is what. So as we know the percentage change formula, we already know that thing. We just need to figure it out. Which of the following will be the correct answer? So we'll see that what is happening. The new value over here is 5.1. This is the new value. And this value is the original value. So we'll see even with the help of Desmos, you can calculate the things, but you must know the basic. So how we gonna use that? The formula that is that more or less is the new value minus the original value divided by original value times 100. So 5.1 minus 5.8 whole divided by 5.8 times 100 that we need to find. Use Desmos for it directly. Use parenthesis 5.1 minus 5.8 whole divided by 5.8, and then you can multiply it by 100. So we'll generate a value which is equivalent to negative 12.06. You will see a negative sign is representing that it is a decrease. So definitely an increase option cannot be my answer. Now all three options are decreased. The closest one is 12.1. So option number A will be the correct answer. Let's just have a look at question number 9. Very good question. The number A is 20% greater than the number B. The number C is 40% less than A. The number C is how many times B that we need to find. So we can use a regression method very quickly over here. How are we going to go there? So first of all, understanding for the question is that A is 20% greater than the number B, right? So what I can say that A is actually B plus 20% of B, right? The number C is 40% less than A. So what I can say that C is nothing but 40% less of A. That means A minus 40% of A. That is the basic constraints given over. And we need to find the number C is how many times B. More or less, we need to find the variation of C divided by B. What is that? Right? How many times? So let's see how regression will help in this. So I'm just using variables A, B, and C because they're regression variables, so no need to change them. But let's use that. So I'm using square brackets for regression as we know now. So A comma C, because A and C values are given. A sign of regression. And if I just use this thing, same to same, it will be helpful. I'm just writing B plus 20% of B, comma, and C is what? It is A minus 40% of A and close the brackets. And there's one thing that needs to be very sure, that the modulus of B should be greater than 0, that we must know. So we're just putting one extra constraint over here. So use curly brackets, use the sign of modulus, and you can write that modulus of B has to be greater than 0 for sure. And that is the full equation that we need to plug in. Now we'll see that the values of A, B, and C are already given to me, that A is 1.2, B is 0.72, and sorry, C is 0.72 and B is 1. We just need to find the value of C by B. So no need to do that. Just write over here C by B. The value stands equivalent to 0.72. If I just write that, this is 0.72. If you want the value in fraction, if it is given, if you want to write the value in fraction, you can do that. So value in fraction is nothing but 18 by 25. So that is 18 by 25. Now this looks lengthy. For some easier calculation, you can understand this thing, that B plus 20% of B can be written as 120% of B, and A minus 40% of A can be written as 60% of A. As 100 minus 40 is more or less 60%. So you can do the same regression with the help of these constraints also. That will also generate the same result. So if I just write A comma C, I'm just removing the above one. I'm just writing it for a reference. Sign of regression, square bracket starts. I'll just write 120% of B, comma, 60% of A, and definitely we need to use the curly brackets where the things has to be positive for sure. So in the modulus, I'm just writing that modulus of B has to be greater than 0. I'm just removing that curly brackets. You will see that the same results are being displayed, whatever we have for the above one. So A is 1.2, this is also same. C is 0.72, this is also 0.72, B is 1, this is B1. So same results we can get. So 18 by 25, 18 by 25 is the correct answer, or 0.72 is the correct answer to this particular question. Now just have a look at the question number 10. It says how many liters of a 10% sugar solution must be added to 15 liters of 50% sugar solution to obtain a 30% sugar solution. So if you just see that this is the basic criteria that has been given, if I just consider 10% of sugar solution as S, right, that I don't know how many liters is, for example, S, and the second solution is given to me, that is 15 liters. So 15 liters is the quantity, and 50% sugar solution means that 50% is sugar and 50% is water. And I need a result as 30% sugar solution. That means 30% is sugar and 70% is water. So let's do that. So if I just write, I'm just taking how many liters is, I don't know. So I'm just considering that variable as S. So number of liters for the 10% sugar solution is, for example, S. So I'll just write 10% of S. I'm just taking that as variable, plus 50% of 15, because that is given as 15 liters. So I'm just writing 50. And we just need to do the regression for this for the 30% of these two values that are being given to me, that is S plus 50. That is the total solution, right? So no need for the square brackets over here. You can use simple parenthesis. Let's see. So 10% of S plus 50% of 15, a sign of regression, 30% of S plus 15. You will see that the value of S also comes out to be 15. That means 10% of 15 liters of solution and 50 liters of 15-liter solution will generate a 30% sugar solution. So the correct answer is 15 liters of 10% sugar solution must be added to 15 liters of 50% sugar solution to obtain the 30 liter of the sugar solution. So 15 liters will be my correct answer in this case. So thank you all for being such enthusiastic participants. We have covered percentage, their application, how to use Desmos effectively. With regular practice, percentage will become one of your strongest topics. If you have any doubts or need help, feel free to reach out. Good luck with your SAT preparation and keep solving problems with confidence. Thank you.